Today, on how it's made. Crayons. A report complete with color commentary. Wooden kayaks. We'll see what keeps this business afloat. Lawnmowers. The grass is always greener at this factory. And gold chains. From the production line to the neckline. It's hard not to wax philosophical about crayons. The average North American kid uses 730 of them by the age of 10. An American chemical company invented crayons in 1903. It took the basic wax crayon it already made for marking crates and barrels and came up with a non-toxic version in different colors. These crayons are made from a combination of waxes, primarily paraffin, which is ideal for making crayons because it's inexpensive and easy to melt. It also has what's called a nice rub-off, meaning it leaves enough wax on the paper. They melt the wax at about 62 degrees Celsius. Then add a secret powder to strengthen the crayon and act as a filler, boosting the number of crayons the wax will produce. They also add various synthetic chemicals. There's one to keep the wax from sticking to the mold, and a fatty acid called stearic acid to improve the rub-off. Now they tint the wax, in this case yellow and red, to produce orange crayons. This factory can produce 127 different colors. Every ingredient in the crayons is non-toxic. After adding more wax, they blend the mixture for about 45 minutes. Now they pump the wax into this device called a rotary machine. It first injects the wax into crayon-shaped molds. Then it envelops the molds in cool water, hardening the wax within roughly a minute. As the molds continue along the circuit, a blade scrapes off the excess, which gets recycled. Just one rotary machine molds more than 2,700 crayons per cycle. With several machines operating simultaneously, this factory churns out 30,000 crayons per hour. The machine ejects the crayons, and a conveyor transports them to the labeling machine. One by one, they drop into the grooves of a revolving drum. At the bottom left, a gluer coats the surface in between the grooves just before the crayons go in. The machine then slaps a label onto each crayon. A roller presses the label against the adhesive, then a little arm wraps it around the crayon. This machine labels 8,500 crayons per hour. The crayons exit the labeling machine and land in a bulk box. Workers sort the crayons by color into the appropriate hoppers of the packing machine. The packaging line is entirely automated. The factory programs the machine to collect a certain number of crayons in specific colors according to the type of pack in production. Their best sellers are packs of 16 and 24. The packing machine is designed to handle the crayons gently. Occasionally, though, a crayon does crack or a label comes loose. When that happens, a sensor automatically stops the machine and a light goes on above the problem hopper. Workers clear the jam, then production resumes. Once the count is complete, the crayon line and the box line meet. A pushing device slides each set of crayons into a box. A built-in scale weighs every box. Should one be underweight, the machine automatically blows it off the conveyor belt. A worker then manually adds the missing crayon, ensuring a full complement of colors for every budding artist. For thousands of years, Aboriginal people in the Arctic have used kayaks to hunt, and for good reasons. These slender vessels glide swiftly in the water and are light enough to carry. High-tech materials make today's wooden kayaks more durable than ever, yet still a glorious way to slice the water. It starts with plywood made from okume, a rugged type of mahogany. A computer-guided routing machine cuts out the boat's various parts. One has finger joints that interlock with another piece to make one long strip. These panels will cover the sides of the vessel and most of the top. The planks are so thin, just 4 millimeters, that the entire kayak will weigh only 17 kilograms. Then there are bulkheads, end panels, footrests, and curved pieces to support the deck and sides. After applying 2 coats of epoxy resin, a craftsman assembles the parts and secures them in a jig for 6 hours until the glue sets. The side panels will span the entire length of the boat at just over 5 meters. Assembling the kayak is pretty straightforward, so if you want to save money and do it yourself, you can buy this kayak cheaper as a kit. He planes and sands the end panels to create a curved tip. He drills small holes, spaced 12 centimeters apart along the edges of the bottom panels. Then he threads copper wire through the holes. This stitches the panels together temporarily, keeping them flexible and thereby easy to assemble for gluing. He places wooden pegs between the side panels to pry them open. Then joins those panels with 2 screws in the front and 2 in the back. At this stage, the kayak is upside down, so they add the bottom panels. He attaches them with copper wire because it won't stick to the resin he'll use to glue these parts together. After flipping the boat, he attaches a bulkhead with more wire. It's one of 2 separators that create stowage compartments. Using a putty knife as a gauge, he ensures the gaps at the seams are even. Then he flips the boat and coats the seams in resin. He lets it dry for 6 hours, just part of the 40 hours it takes to build the kayak. Before the glue hardens, he makes sure the top of the boat is level. This way he can adjust the pieces if he needs to. After removing the wire from the seams, he applies more resin to these areas. Over this, strips of fiberglass cloth to form a watertight seal. He'll also apply 3 more coats of resin throughout the inside of the kayak. Once it dries, and he sands and varnishes the entire surface, the craftsman adds the footrest assembly. This one's got pivot pads with cables that control a rudder to help steer the boat. This is an optional feature. Otherwise, there's a simple foot brace and you just use your paddle to go with the flow. Next, craftsmen apply resin along the kayak's upper rim. They add the top panel to form the deck. Then they wrap the entire boat in packing tape, which compresses the panels as the resin sets for 12 hours. These pieces form a raised rim around where the kayaker sits. A waterproof skirt fits under this rim, keeping the area dry in the water. The deck gets 2 coats of resin. An hour later, they spread fiberglass over the bottom to seal and protect the wood. The bottom then gets 3 coats of resin. Next, they spray on up to 6 coats of varnish, depending on the type of finish the boat will have. This protects the wood from sun damage. They add a foam backrest and a seat for your comfort on the trek. And finally, flexible rubber straps. They're for securing your harpoon, or more likely, your paddle. Either way, you're in for quite a trip. Gardeners' jobs got much easier in 1830 with the invention of the first mechanical lawnmower. Nowadays, most lawnmowers have electric motors or gas engines. They turn blades that are either on a reel and cut like scissors or rotate like a propeller to chop the grass. These gas mowers have rotary blades that spin horizontally on a vertical crankshaft. To make the blade housing, which is called the deck, a machine first applies a lubricating chemical to sheet steel which was coiled when it came to the factory. The chemical helps flatten it, so it's easier to cut. A press then perforates the sheet every 60 centimeters. After the press separates the segments and rounds off the corners, a robotic arm moves each segment onto a die. A 500-ton press bends the steel like tin foil between 2 molds to give the deck its basic shape. A robot lifts the oily decks with suction cups and moves them to another press. This machine trims away the excess around the deck's edges. Another machine bends the sharp bottom lip inward to make the deck safer to handle. The factory uses robots because they work faster than humans, processing 500 decks an hour. After a thorough cleaning, the decks move into an electrostatic paint booth. They lace the powder paint with a negative electric charge, the decks with a positive one. This draws the paint particles onto the decks, creating a thorough and even coat. The factory's 6 paint booths are on tracks, so when it's time to change color, workers can easily switch the entire chamber for a clean one. The paint cures at 190 degrees Celsius for 15 minutes. This press bends 2.5 meter long tubing to form the mower's upper handle. Another press bends 1.8 meter long tubes to make a shorter, lower handle. Workers will later attach the 2 handles to form one folding handle. By folding, it takes up less space in the shipping box and later in your garage. Here's the mower's 5-horsepower engine. A worker attaches it to the deck with 3 bolts. He uses a powerful torque gun so the bolts won't loosen because of vibrations. Later, workers will mount the blades to the engine's crankshaft that protrudes through an opening in the deck. Next, workers install a plastic rear door through which the grass clippings eject. This door attaches to brackets which have levers that adjust the mower to 9 different height positions. It's time to mount the plastic rear wheels. Next, an adapter to stabilize the blade on the crankshaft. Then, the blade. It's wider at each end to create the proper airflow inside the deck. They secure the blade tightly with a powerful wrench because it's going to spin at 3,300 RPM. The front wheels are 1/3 smaller than the back ones. This makes the mower easier to maneuver over uneven terrain. They put rubber covers on the height adjustment levers so they're softer on the fingers. The mower adjusts from 2.5 to nearly 9 centimeters off the ground. They secure the lower handle. Then loosely attach the upper handle to the lower one. The consumer can tighten this after shipping. They add a safety handle that turns the engine off if you're not squeezing it against the upper handle. It attaches to a caliper system, much like what you'd find on a bicycle. Finally, workers apply labels to indicate the mower's horsepower and width. Fill her up with gas, and she's ready to cut your lawn down to size.
How it's made. Brought to you by your local home hardware. Help is close to home.
Some of the first gold chains date back to the ancient cultures of Iraq and Greece. They were symbols of wealth, royalty, and the divine. Lucky for us, jewelers now make these personal treasures more affordable and more durable than ever. But you may be surprised to learn what they put in the gold to make it better. Pure gold is fairly soft and bright yellow, so it's common to create an alloy to strengthen it and alter its color. Copper lends a reddish hue, and brass helps the alloy melt more quickly than gold and copper would alone. Depending on the ratio, adding these metals produces 14 or 18 karat gold. They melt the mix in a crucible at 1010 degrees Celsius. Just 3 of these scoops are enough to make about 5,000 14 karat gold chains. A worker pours the molten alloy into a casting machine. Water cools the metal to around 370 degrees Celsius, solidifying it. The metal passes through a round die, which shapes it into a golden rod that's nearly 2 meters long. After cutting the rod in half, workers pass it through what's called a breakdown mill. The machine reshapes the rod from round to square, so it'll be easier to stretch. Next stop, a tandem mill. It's got 12 rollers that stretch the rod until it's about as thin as a piece of spaghetti. As it emerges, rollers shape the rod into a coil that's 24 meters long. Workers soften the coiled metal in an oven. Then they uncoil and continue stretching what's now a wire by passing it through a die lined with industrial diamonds. To prevent overheating, the machine sprays lubricant to cool the wire while reducing it to the width of a human hair, its final size. The wire then winds into a nearly 2,800 meter long spool. Next, they unwind 32 of the spools and run the wires through another oven to soften them even more. Just in case you're thinking working here is a golden opportunity, you should know that security is very tight. Employees must pass through metal detectors before going home, and wearing jewelry to work is strictly forbidden. This machine makes what's called cable chain. It passes wire through a link and closes it to make another link. The machine makes 600 links per minute. Here, a worker does a random quality check. This machine makes a chain in what's called a Venetian style. The wire passes through a channel where mechanical jaws bend it over a die to make a link with the preceding segment. To make what's called a spider style, this machine passes a wire through up to 5 loops before closing the link. For a Figaro-style chain, this machine makes 3 short links before a mechanical arm moves the chain to another area to add 1 longer link. The arm then moves it back to add 3 more short links. The simplest style is what's called a rope chain. To make it, this machine threads a wire through as many as 2 loops, then closes it to make another loop. They coat the finished chains with a lubricating powder that prevents the links from sticking to each other during the next step, when they heat the chains to 815 degrees Celsius. This activates a soldering agent added to the metals earlier. It fuses the ends of the links to each other. This machine welds a link to a clasp on the chain. A tag indicating the gold quality goes onto the clasp. Finally, the chains go through 4 chemical baths, which thoroughly clean them. Then workers plate them with a layer of 14 or 18 karat gold. Plating gold with gold creates a more vibrant finish. After one last quality check, these chains are ready to dazzle their way to a neckline near you.